In this video, we're asked to find the 6 trig functions given this triangle over here. Now, in order to do this, you need to know all 3 sides of the triangle. And since it's a right triangle, we can use the Pythagorean theorem to help us find the hypotenuse of this one. Now, some of you might know what a 3, 4, 5 right triangle is, but I'll show you why this is 5 here in a second. If I take 3 squared plus 4 squared equals c squared, right? A squared, b squared, and c squared. If I do that, here this is going to be 9 plus 16 equals c squared, and of course c squared equals 25. So c, the side itself, is just going to be 5. This is a 3, 4, 5 right triangle. Now when it comes to finding these trig ratios, we're usually pretty good at sine, cosine, and tangent, right? Sine is going to be, compared to my theta, it's going to be the opposite over the hypotenuse, or 3/5. Cosine is the adjacent over the hypotenuse, which is 4/5. And tangent is going to be opposite over adjacent, which is 3/4. Again, compared to my angle theta, 3/4. But what we might not be as good at is cosecant, secant, and cotangent. Now, if you can know the order of these, it's really nice because cosecant and sine line up, secant and cosine line up, and cotangent and tangent line up, okay? So what I mean by line up there is that cosecant is just going to be sine flipped. All right, so instead of 3/5, it's going to equal 5/3. That one flipped. Secant of theta is going to equal 5/4, and that means cotangent of theta equals 4/3. All right, so this one is pretty easy. Let's see if we can try one that's a little bit harder with numbers that maybe aren't as nice as 3, 4, and 5. All right, the second one here at first glance looks almost identical to the first one, right? We have a 3 and a 4, but remember that was a 3, 4, 5 right triangle where 5 was our hypotenuse, the longest side. Here our longest side is the hypotenuse, which is 4. So that means that this is not going to be a 5. We can actually use the Pythagorean theorem to figure it out. Here, if you think it's going to be 3 squared plus maybe b squared, I'll leave it as b because I don't know, equals this c squared, which is 4 squared in this case. We can solve for the b and figure out what this missing side is. All right, so it's going to be 9 plus b squared equals 16. Subtract 9 on both sides, and b squared equals 16 minus 9 is 7. All right, so I don't want b squared though, I want just b. So take the square root of both sides and we get b equals the square root of 7. So that's what's going to be right here, the square root of 7. And with that, I can now find all of these. All right, it does help if you have a theta in there. So let's put our theta at the top. And compared to this theta, we're going to figure out our 6 trig functions, starting with sine. Sine, of course, is going to be the opposite over the hypotenuse, or 3/4. Okay, cosine is going to be the adjacent over the hypotenuse. The adjacent compared to my theta is the square root of 7/4. Square root of 7/4. Tangent is going to be the opposite over the adjacent, 3 over the square root of 7. And this is one where you're going to have to rationalize this denominator. A lot of teachers don't like when you keep the square root of 7 down here. And so to rationalize it, remember you multiply by that square root over itself. So the square root of 7 over the square root of 7. What this does for us is, on the top, it's just going to give us 3 square roots of 7. One's on the outside, one's on the inside of that square root, so they cannot be put together. But on the bottom, the square root of 7 times the square root of 7 is the square root of 49, which you can skip that and just say it's just going to be 7, right? This number without the square root is just 7. Okay, now for us, the 3 and the 7 can't simplify. If they could, you can maybe make it look a little bit better, but we'll have to leave it like this, 3 square roots of 7 over 7. Now, for the other ones, remember, kind of cosecant lines up with sine and so on, you can just flip those. All right, so for this one, for sine, I can just flip 3/4 to be 4/3. Okay, secant, I can flip this to be 4 over the square root of 7, but we're going to run into that same issue that we had down here, where I have to multiply it by that square root of 7 over itself because it is not rationalized. All right, so if I take this times the square root of 7 over the square root of 7, this now gives me 4 square roots of 7 over 7. And so that is what secant will be. Cotangent, a little trick on this one, is you can go back to a previous version of what you had before you finally rationalized it. What I mean by that is if I go back to this version right here, this 3 over the square root of 7, I can just flip that all right, and give me the square root of 7 over 3. And that might be easier than having to flip this one. If I would flip this, I'd end up with the square root on the bottom, have to go through the process of rationalizing. It would just take too much time. But if I go here, the square root would end up on top, and I think that makes it a little bit easier. All right, so that's how you find the 6 trig functions given a right triangle.